All right, so we're going to talk chemical and physical properties. This is a really, really important lesson, and we are going to continue to utilize this as we go forward, especially with our Unit 2 lab. But by the end of this, I want you to be able to distinguish chemical and physical changes and be able to identify them. Like if I give you an example, you should be able to state if it's chemical or physical. And you're also going to learn to calculate densities. So, physical properties. These are things that help you identify the type of matter that you have. These are things that you can observe or measure just having a piece or sample of the matter right in front of you. All right? And physical properties are often related to physical changes. So, you're going to have your evaporation condensation point. All right, so that's a physical property is going to be the temperature at which evaporation happens. All right, you can also think of that as like your boiling temp. You're going to have melting and freezing points. All right, so that's the temperature of freezing. All right, so like water freezes at 32 degrees Fahrenheit. That's the physical property of water, and then the change is that it either goes from solid to liquid or liquid to solid. Okay? Density is something we're going to talk about in more detail, but that is a physical property. Magnetism, whether or not something is magnetic. Odor, all right, if sulfur has this like a smell to it sort of thing. And then there's a bunch of examples in the reading lesson. So density is a really, really helpful property in the sense that if you have an unknown substance in front of you and you are able to measure its mass and volume, you can calculate its density and then use that against a table of known information like this here and figure out what you have. All right? So the trick to doing a density calculation right is knowing your units for mass and volume. All right, so see if you can come up with any, and especially if you are unsure on some of them, you're going to want to write these down. But mass units are going to be grams, all right? So you might see the word gram, you might see the abbreviation gram. There's also the different metric sizes. So you've got kilograms if you're talking like a mass of a human, milligrams if you're talking about maybe the mass of a powder, things like that. So if you see any of those, that's going to be your mass value. Volume, all right, if you're working with a liquid, you might be dealing with liters or milliliters, all right? Or if it's, say, a cube or something like that, you might work with cubic centimeters or meters cubed, all right? So just, have these in the back of your mind so that as you read a problem, if it's not explicit about which value is mass and which is volume, you can use the units to figure it out. So, density is the measure of the amount of mass in the space taken up by a substance. All right, so you calculate density by taking its mass and dividing by its volume. All right, so your units for density are going to be something like grams per centimeter cubed, or milligrams per milliliter, or kilogram per meter cubed, something like that. So, here's an example. You have 134 grams of a certain metal that takes up 15 centimeters cubed. What is the substance? This is where knowing which units apply to which variable helps. All right, we know grams is a measure of mass. So my M is going to be 134. All right, and then I know that centimeters cubed is a measure of volume. So my volume is going to be 15. So I'm going to do density is equal to 134 divided by 15. And that gives me 134 divided by 15, 8.93. My units are going to be grams per centimeter cubed. All right, and now I can go to this table over here And I can see, well, which substance has a density of really close to 8.93? And that is where I can see, oh, copper, 8.93. So here you go. You've got a material weighs 12 grams and takes up 4 cubic centimeters of space. What is the material's density in grams per cubic centimeter? So you try this one on your own, see what you get. All right, density equals mass over volume. Grams are mass. Cubic centimeters, that's this guy. All right, so that means 4 is our volume. So we're going to have 12 divided by 4, which equals 3 grams per centimeter cubed. Chemical properties, on the other hand, are not something you can observe just holding the piece of chemical substance in your hand. You've got to put the chemical substance through a reaction to observe chemical properties. All right, so chemical properties are related to how a substance reacts or what kinds of reactions it might go through. All right, so like a chemical property of some metals is that they react with hydrochloric acid to make a gas. Or certain substances have chemical property of burning in the presence of oxygen. Certain types of dissolved matter form precipitates when exposed to a different dissolved matter, right? The key is that this is all going to relate to how they react, to how the substance reacts. So you've got to have a reaction going on in order to see and observe these chemical properties. So, which of the following is a chemical property? At room temperature, oxygen is a gas, but iron is a solid. Water will not burn, but gasoline is flammable. A diamond is harder than chalk. Butter melts at room temperature, but Jell-O does not. So, which of these is a chemical reaction taking place? It's actually going to turn the matter into something else. You hopefully said this, all right? Because like when we burn gasoline to run our cars, all right, we end up giving off carbon dioxide and water vapor, and then get energy out of the reaction to run our vehicles. All right, the rest of these are just things that you can observe about oxygen sitting in front of you and iron sitting in front of you, or a diamond. You can have a diamond in one hand and chalk in the other and be able to observe the hardness. Melting is a physical change because it's like melting point, right? Butter is still butter, it's just melted butter. So, getting into chemical and physical changes, these are going to be when the matter changes based on one of these either physical or chemical properties. All right, so physical changes, you know something is a physical change because your substance is still molecularly the same thing. So this is like the butter melting, right? Butter is still butter, it's just instead of solid butter, it's liquid butter. So like ice melting, it's still water, it's just liquid water, all right? You can also take something and just break it apart. So if you take a piece of chalk and you crack it into two, it's still chalk, it's just now 2 pieces of chalk instead of 1. Right? So changes in state, stuff where you know that there's not a chemical reaction taking place, you're molecularly, what you started with is what you end with. All right, and that's where dissolving comes in. This is one that often gets confused by my students. And when you hear an example of dissolving, I want you to think of salt water. All right? If you've ever gone swimming in the ocean or maybe gargled salt water when you have a sore throat, all right, salt water tastes salty. So when you mix water and salt, does the salt disappear, become some new chemical, or is the salt still there? Since you can still taste the salt is still there. All right, so when you dissolve something in water, you're not changing anything's molecular makeup, all right? It's just that what's happening is that the water molecules are surrounding the salt molecules, and they're doing it really, really evenly and making a homogeneous mixture, all right? Chemical changes, on the other hand, are going to actually change the chemical makeup of your substance. So what you start with isn't the same chemical you end with. All right, so like if you take water and you split it into hydrogen and oxygen, that's a chemical change. The easiest way to spot a chemical change is to keep an eye out for common signs of a chemical reaction. There are 5 you want to be familiar with. All right, so drastic color changes. If you take something like 2 clear liquids and combine them together and it turns yellow, that's a drastic color change. All right, so if you take a blue liquid and a clear liquid and then it gets a little less blue, that's just diluting. But if you combine pink and brown and get green, that's something crazy. All right, a gas being given off. All right, so Alka-Seltzer is an example of this. You're going to know this is happening because you see bubbles. All right, that's going to be an example of a chemical reaction taking place. Energy being released or energy being absorbed. This is most commonly observed with a temperature change. Energy being released can also happen if you get light. So like these little, I don't think people actually do roller skating parties anymore, but at a club or something like that, you might use the little neon glow sticks, right? And you have to actually kind of like crack and combine the chemicals to get the glowing to start. The last one is a precipitate. All right, so then let me say that again, precipitate. What this is you take 2 liquids and a solid forms. That solid forms because of a reaction. All right, because it wasn't there in the first place. So, a couple of practice type things. So Susie drops a magnet and finds that it is no longer magnetic after dropping it. What has happened in terms of its particles? A chemical change occurred that changed the iron into nickel. Oh, and I'm sorry, this was supposed to say an iron magnet. All right. A physical change occurred in which the iron remained iron, but lost one of its physical properties. Or a chemical change occurred in which the iron remained iron, but lost one of its chemical properties. All right. So dropping a magnet is not going to magically turn it into nickel. So let's just get rid of that one because that's just silly. All right. So now is this a physical change or a chemical change? All right. So the iron remains iron. So that should tell you your answer right there. The iron remains iron. That is a physical change. All right, because for something to be a chemical change, iron has to turn into something else. So B is your right answer here. And you can confirm that because on our list of physical properties, magnetism is one of them. All right, one last set of practice. Pause the video, see if you can decide which of these are chemical and physical changes. Just put a C or a P, and then start it back up and see if you're right. So melting ice, all right, solid water to liquid water, still water, it's a physical change. Dissolving sugar into water, all right, think of it as like, Kool-Aid and stuff like that. Sugar's still there, you can still taste it. Dissolving is a physical change. And exploding firecracker. So this makes noise, this gives off light. It also changes colors usually. So those are 3 signs of a chemical reaction. All right, so there's a chemical change. Ripping paper. So if you take a piece of paper and you rip it in half, it's still paper. It's just 2 pieces instead of 1. So that's physical. Transforming water into oxygen and hydrogen. So you're taking water and you're turning it into something different. Hydrogen and oxygen. And that's a chemical change. And reacting acid in a metal. So if I'm reacting something, all right, a reaction means that I'm telling you a chemical reaction is taking place. So that's going to be a chemical change.